In this lesson, you will learn how to multiply binomials with radicals. Let's take a look at the first example. In this problem, you want to distribute the radical 3 to each term in the parentheses. So remember, when we are distributing, we are multiplying radical 3 times each term. So let's start with radical 3 times 2 radical 5. So radical 3 times 2 radical 5. Now remember, when you're multiplying radicals, you can only multiply numbers outside the radicals together, and then you can multiply numbers under the radical together. Now in our first radical, radical 3, there's no number outside the radical, although you could put a 1 there if you'd like. If you do that, you would simply be multiplying 1 times 2, which is 2. Then you could multiply the numbers under the radical symbols, which in this case would be radical 15. We will then multiply the radical 3 times the other term in parentheses, the 3. So we have radical 3 times 3. Because in the first term the 3 is under the radical, and in the second it's not, they cannot be multiplied together as in 3 times 3. All you can do is simply put them together as 3 radical 3. And because it's positive, we will place a plus sign between the two terms. We cannot simplify this any further because in order to add radicals, the numbers under the radical would have to be the same to be like terms. So this would be as far as we could go in this particular problem. Let's look at additional examples. Again, in this example, we're going to distribute the radical 2 to radical 6, and then we're going to distribute to 3 radical 8. When we multiply radical 2 times radical 6, because the 2 and 6 are both under the radical symbols, we get radical 12. Then when we multiply radical 2 times 3 radical 8, the negative 3 just drops down, and then we will multiply the 2 and the 8, which are under the radicals, to get 16. Now we need to look if we can simplify the numbers under the radical symbols. Starting with radical 12, 12 can be broken down using a factor tree. So we will have 2 and 6, and then 2 and 3. So our prime numbers are 2, 2, and 3. If you multiply the pair of numbers together, we would then have radical 4 and radical 3. So radical 12 is broken down into radical 4 times radical 3 to create at least one perfect square, which in this case is radical 4. So radical 12 simplifies to 2 radical 3. In the other part of our problem, we have radical 16. This is a perfect square, so we will just drop the 3 down, and then 16 will become a 4. Then we just simply multiply the 3 and the 4 together. So our final answer is 2 radical 3 minus 12. Let's look at an additional example. This problem is read as negative radical 2 minus 6 radical 7 quantity squared. So because the binomial is squared, that means we need to multiply it by itself. So we literally need to write the binomial twice. Now a binomial times a binomial requires us to FOIL it. So we're going to have to go slow and take one term times the next, and then that same term times the second term in the second parentheses. That's how we will begin. So we have negative radical 2 times negative radical 2. That would be a positive radical 4. Then we have negative radical 2 times negative 6 radical 7. And that would be a positive 6 radical 14. because I need to multiply the 2 and the 7 since they are both under the radical symbols. We will now switch and multiply the negative 6 radical 7 first to the negative radical 2 and then to the negative 6 radical 7. So negative 6 radical 7 times negative radical 2 is a positive 6 radical 14. And then we will multiply negative 6 radical 7 to negative 6 radical 7, which would be positive 36 on the outside and radical 49 on the inside. We then need to look and see what we can simplify under the radical symbols. Radical 4 is a perfect square, so this will change to 2. In the middle, you may not realize, but we can actually combine those together. They are considered like terms, as long as the numbers under the radicals are the same. To combine these together, we simply add the numbers in front of the radicals together, leaving the radicals exactly the same. So this would give us 12 on the outside because of the 6 plus 6, and radical 14 on the inside. Then we have 36 radical 49. So we will drop down the 36, and then radical 49 is a perfect square, so we will change that to a 7. The last thing we need to do is simply multiply the 36 times the 7. Everything else will simply drop down. So we'll have 2 plus 12 radical 14 plus, and then when we multiply 36 times 7, we get 252. From here, 2 and 252 are like terms because they don't have any radicals attached to them. So we will change that when we add them together to 254. Then we will just slide over the 12 radical 14. Let's take a look at the next example. In this example, we also have a binomial times a binomial. So again, we must use the FOIL method. So first we will multiply radical 5 times radical 5, which is radical 25. Then we will multiply radical 5 times 4, which is 4 radical 5. Then, starting from the inside of the first parentheses, we will take the negative 4 and multiply it by the radical 5, giving us negative 4 radical 5. And then multiply the negative 4 times positive 4, giving us negative 16. Now we will start simplifying. Radical 25 we can change to 5 because it's a perfect square. We have like terms in the middle. 4 radical 5 minus 4 radical 5 actually equals 0, so those can cancel out. From here, we're going to drop down the minus 16, and now we're just left with our regular numbers, 5 minus 16, which is negative 11. Let's go to the next slide. Radical 3 plus 6 times the quantity 1 minus 4 radical 3. So again, we will FOIL this. Radical 3 times 1 is radical 3. Radical 3 times negative 4 radical 3. Since we need to multiply the 3's under the radical, we would get negative 4 radical 9. 6 times 1 is 6. And then 6 times negative 4 radical 3 is negative 24 radical 3. We now look to see what we can simplify. Well, first of all, we have like terms because radical 3 and negative 24 radical 3 have the same number under the radical symbols. We can stick a 1 in front of the radical 3 so that we actually have a number to subtract 24 from. So when we combine those, 1 minus 24 would be negative 23 radical 3. The term in the middle, negative 4 radical 9, the radical 9 can be simplified to just 3 because it's a perfect square. So we would have negative 4 times 3. Then we can drop down the plus 6. So from here, I'll drop down the negative 23 radical 3. I'll multiply the 4 and the 3 and drop down the plus 6. Lastly, I'll combine the negative 12 and the positive 6, and when I add those together, I get a negative 6. So the final answer is negative 23 radical 3 minus 6. And this completes the lesson on multiplying binomials with radicals.